My name is Sai Preetham Vinakota, and I'm doing this project alone. So the name of this project is DOTA2 Hero Recommendation, and uh, this is going to be my final project for CSCI 5253. So, coming to an introduction of this project is based on a game called DOTA2. This game is developed by Gabe Newell, who's commonly known as Gaben in the gaming community. This is a very popular strategic game on Steam Engine with a global fan base. I'm one of the players who play this game on a regular basis. Some other trivia on this game is it hosts a tournament called the International or the TI, which has a prize pool of around 40 to $50 million. So, and this game is played by hundreds of thousands of players globally. So, coming to the gameplay, where the players use my model, my service. So, this is one of the main screens that the players see. And there are 10 players in each game, so 5 on each side, and each player needs to pick a character in order to play this game, and that character is called a hero. So if I'm going to play this game and I'm assuming that my hero is the last one to be picked, so I'm assuming for this project that there are already 9 players who pick their heroes, and I am the one who is picking my hero at last. So for my hero, I'm going to use this service, and hopefully the service gives me a hero that is going to be mathematically the best for this game in order to win. So the goals of this project are uh, firstly to automate the hero recommendation during the drafting phase. Next is to leverage machine learning to optimize the win probability based on the team composition. Provide a user-friendly web interface for real-time recommendations. Facilitate players in making data-driven hero selections. So these are all the goals that I've set for this project, which makes it simpler for the players to pick their hero in this picking phase. The components that I've used for this project are listed here. And some of the main components in this project are the machine learning libraries, the Google Colab, which I've used to code the model, the drawing the API, drawing data from the API, and the API that the website that I've used to get the data from is called Open Data API, Open Data API. And for storage of this data, I've used Dota buckets. For version control, I've used GitHub, and for a virtual environment, I've used Google Cloud Shell. Coming to the and this is the architectural diagram of this project. So this project draws data from a website called Dota Open Data API, and it pre-processes that data into a perfect data set and gives that data set to the recommendation model. And this is done continuously. So whenever there is a new match and whenever that match is updated into this Open Data API, this model draws that match and it pre-processes. For example, by pre-processing, I mean it converts that data, uses one hot encoding, and it converts that data into binary, which is the most efficient way for this recommendation model. I'll show you all about that in a few minutes. So uh, the recommendation model then takes input from the web interface which the player is using. So the player inputs all the other heroes that the other players have picked, and and the player inputs all the other players, and this other player's data is going to the recommendation model. It uses all its algorithms and recommends a best hero for the player to pick on the web interface again. And these all is done in the Google Cloud platform, so it's not done on any local machine because this is a web service. And for debugging, I need to show you this Google Colab notebook for debugging. So this is the one hot encoding that I was talking about, and this is the algorithm. This is a model with a test accuracy of 92%, 93%. So this is a small code that I have created for this project. So this code is helpful for me to debug when there is a where to check if there are any issues with the model. So how do I check the issues with the model? So these are the hero IDs. So every hero, there are certain heroes called Crystal Maiden, Axe, Bloodseeker. There are so many. There are around 126 heroes. There are 126 heroes in this game, and each hero is mapped to an ID. So whenever a hero name is given as an input in the web service, it is taken as it is converted into an ID, and that ID is useful for this model to work. So these are the hero IDs, and based on these IDs, the model recommends me out another hero ID as an output. So this is the recommended hero. So for example, this 33 is based on these numbers. For example, if I alter this to be 2 instead of 20, I get another hero as recommendation. For example, if I do 15 as a hero, and I get 35 as a recommended hero. So this is how I used to debug. If I get null or nan, or if I don't get anything, if I get a single number for every input, so that is how I debug. That is how I found out if there are any errors, and there were so many errors that I solved. So another part of my programming is this. So when I use this code, it it uses Flash to get another website. So it I can go to the so now that the website is online, I can go to the website, and this is the UI that I've set up for the players to use. So for example, if I'm inputting these heroes, let's assume that these are the heroes that are picked by the opponents. Oh, if these are the heroes that are picked by the opponents, then I get, if I click on recommend hero, then the recommended hero is Max, according to the model. So this model is saying that based on the heroes that you've input into this model, based on the heroes that the allies and the enemies have picked, the hero called Axe has the best chance of winning this game. So what there are some things that I could have done better in this project, and one of those things is building a better UI. But I don't think this is the main concern of this project, because this project is about using different tools like GCP and HTML, and uh, using ML into these, and creating an end-to-end project. So there's my project. Thank you.